I'm Maggie Stark, and this is Marion Azoulai, and we're both on the data team here at Astronomer. And so today we're going to be talking about our recent re-architecture of Airflow and sort of the road that got us to needing to do that. But first we'll start with the introduction of Astronomer. So Astronomer helps manage the open source software Apache Airflow, which I think everyone is pretty familiar with here. And so they're really helping to shape where that product is going. We also do a lot of work around education of Airflow, best practices, use cases that you can put through Airflow, through our Academy and our docs. And then on top of that, Astronomer has a managed Airflow service called Astro that makes it easier and more efficient for our customers to manage their Airflow infrastructure. So that's kind of a brief overview of Astronomer, and now I'm going to pass it off to Marion to discuss what our team specifically does.
Yeah. So, but our team, we're all cat lovers to start with. Not true. So we're a centralized data team. We build primarily critical operational pipelines with Airflow for a lot of internal customers, such as like all the departments at the company and the executive team, for example. But we are also, in a way, product influencers because we are, in fact, doing all our work with Airflow and Astro. So we are our own internal customer, which means that we get to experience the product firsthand, which means that, of course, like we share with the product team like any product gaps or enhancement that we feel like could be useful. We also inspire the product team with some features like some of the custom works that we do on our own architecture have been turned into product features. And finally, we even contribute directly to the product. In the Astro UI, there are some embedded dashboards, which the data team built using Airflow and Astro metadata that we are collecting and processing using Astro and Airflow. So it's like super meta. Just in a few words, our data team ecosystem, so it's like quite traditional ELT work. So we have like a bunch of data sources, all the regular stuff, like Salesforce, HubSpot, GitHub, Notion, Google Sheets, like a lot of different sources that we ingest into our Snowflake data warehouse. Then we have like different levels of like data processing, from modeling to mapping between different objects, and then other layers of metrics and marks, which we end up using for building reports, for reverse ETLing into some of like the tools that we ingested from, and delivering insights and data to everyone in the company. These are just like a few of our use cases. So, as I said, we have the embedded dashboards. We do a lot of application integration, account scoring. So that's more for sales, like lead and customer scoring, a lot of ad hoc analytics, product testing, obviously. We do a lot of dog fooding. So these are like some of our use cases. And now I'm going to hand it back over to Maggie, who's going to explain to you how we initially built our architecture to serve all that work to our internal customers.
Yeah, so this is all sort of the projects that, well, not all, but a lot of the projects we're supporting now. But if we go back to our initial days on the data team, and we were all sort of doing data projects, but nothing was operationalized and it was ad hoc. So we had this backlog of stuff that we needed to start operationalizing, and we needed to figure out how to do that and how to do that efficiently. So we have this backlog of projects, and we have a lot of data team members that are new to Airflow. So when we were talking about our initial implementation of Airflow, we needed something that was going to be simple to onboard, just to get users up to speed quickly and also get those projects online quickly. So that was something that was important with our initial architecture, was just quick onboarding. The other thing we really focused on was governance. We wanted to make sure that we were starting with good practices of data and Airflow. So to do that, we ended up implementing a DAG factory. The DAG factory we use is Gusty, And the benefits of the DAG factory is it really abstracts airflow from the user. So we were able to keep our data team members in the context that they were comfortable with. They didn't need to know a lot of Airflow to start using Airflow. They were able to generate pipelines using their SQL files, their Python files, or whatever context they wanted to be in. And then the other thing that we worked to implement was custom task groups. And so I think it's pretty common to use custom operators. And so custom task groups is just kind of a play on that. You end up making a package of tasks to do common operations. So in our pipelines, we had very common themes. We're either ingesting data, we're transforming data, manipulating the data somehow, or we're delivering it somewhere. So taking each of those operations and creating custom task groups to cover those use cases allowed us to prioritize code reusability and also act as a contract mechanism for production suitability. So everyone that is transforming the data is going through the same steps. And so that just ensured that our pipelines were manageable and everyone was doing the same processes. So as our pipelines grew, we sort of naturally depended on sensors in the beginning. And so when we were initially implementing this, asynchronous sensors weren't commonly available. So over time, we were just swapping those in to production as they became available just for resource management. But we were heavily sensor dependent in the beginning. And that'll be a key thing in this talk. So I just want to show an example of what our custom task group looks like. So this would be our create table task group. We end up writing one SQL file. So you see some SQL here at the bottom. And the front matter includes all the configuration for the pipeline. So you end up having your table documentation and your field documentation. And that drives our data catalog that allows our other members of our company to easily explore the data that we're producing. And then you have like what schema it's going into, primary keys, testing. We have two kinds of tests that like fail our pipeline, block everything downstream of it, and sort of validation, sanity checks, like something's not quite right, but it's not worth blocking everything from running. We'll address it in a PR. And so this one SQL file ends up turning into several tasks. So I have create my table, test it, ensure it looks right, and then swap it into production, document the table, do my sanity checks, and that's one. So one file has turned into n number of tasks. So, and having this documentation and testing framework was really important to us in the beginning because if you get behind on those things, it's really hard to implement later and catch up. So we put up a lot of attention into making sure those worked in the beginning. And they still work now, just to be clear. So this is all really great. The DAG factory and the custom task groups were great. They really allowed us to scale our tasks. So we went to almost 30,000 daily tasks running in each of our environments within about a year and a half. The issues became when we're growing this many tasks, our DAG dependencies are becoming more and more complicated, and with that, we're getting a lot of sensor growth. And so I'll hand it over to Marion to talk about what happens when you have a lot of sensors.
Yes, thank you, Maggie. So just to give you a bit of context, as you can tell from my accent, I'm French, and I live in Europe, which means that I'm like 6 to 9 hours ahead of time compared to all of my coworkers in the data team. So I'm the one who's on the line to debug the pipeline and monitor it every morning. So, usually, like I start my day, I have a coffee, and then I open Astro and Airflow, and I check the pipeline. And, at first, like before we started like really scaling our pipeline and building more and more tasks, like things were mostly all good. Like we had a few legit failures, but mostly things were good. But then we started experiencing more and more issues. So this is actually like a real life snapshot of my daily pipeline report that I share with the data team. So here it reads, oh no, the pipeline is all red again. And I started having, more and more of those. Like the next day, pipeline is a hot mess today. And then, oh no, prod is behind, poop emoji. And then many task sensors timed out. So, it started being like, not daily occurrence, but almost like every day, the pipeline would be like all red. And I had to deal with that because I was the only one awake. It was not fun. So why did that happen? Oh, before I get into the why, like this is like the actual numbers. Like we are a data science team, so we also we don't do just qualitative analysis. We also look at numbers. So in the course of like little over a year, our failure rate went from 3% to 19%, and that was bad. So now I'm just going to go through why, what are the pain points, the challenges of a setup that is highly dependent on sensors. To give you an idea, at the, back when like all those issues were happening, we had about 120 different sensors that were running multiple times a day and managing the interdependencies between our DAGs. So it was like really, like our whole pipeline was sensor dependent. So what does it mean in terms of challenges? So the first thing, it's obvious, the over-reliance on task and DAG sensors means that you have a complex architecture that is more fragile and prone to bottlenecks, sensor times out, things like that. Then the second issue is cascading failures. Obviously, you have one task and one DAG that fails, all the downstream DAGs are going to fail too. And you end up with your pipeline being all red. Thirdly, you have a more complex error diagnosis. So you wake up in the morning, you have your coffee, you discover your all red pipeline. Now you need to figure out what's the root cause. So it takes a lot of remembering, like having a mind map of like how each DAG depends on the next to get to the root cause. And we had at that time like maybe like 80 or more different DAGs. So I mean, I could still kind of manage, but it was like very time consuming. And it was not scalable, and it would like take a lot of time. And so obviously that leads to delayed response time and prolonged system efficiencies. So once you've found the root cause of your problem, then you need to fix it, and then you need to bring your pipeline back to health. And again, in a sensor-dependent architecture, that is more costly and more complicated because you need to rerun every single DAG in the right order, or otherwise you're going to create like some data issues. So that was also, causing more delays and like honestly taking up a big chunk of my day. Next, of course, like you're more at risk of hitting the system limits. And in fact, that's something that happened quite often. Like we had, on a regular basis, we had, like dozens of sensors running at the same time, waiting on a bunch of DAGs. And so we would hit like the parallel task limits or other like resource and compute limits. So, that leads to performance degradation. And then, of course, that's also excessive compute, which means that we were spending more than we were supposed to. And, next thing you know, you get a call from finance. So not great. And then scaling challenges. So of course, a sensor-heavy architecture will exponentially increase the complexity and the resource needs. So it's not that at some point you cannot like just keep adding more DAGs, or it's like way too complex of an architecture. And even like in terms of development, like if you want to add a DAG in the middle of your pipeline, like it can be really error prone and complex, and you need to understand the entire pipeline and the existing interdependencies to be able to add the right sensors at the right place. So it makes it really like difficult to add just a single DAG. So as you understand, like this architecture was not really something we could maintain on the long run, and we had to do something about it. Not only because of all the reasons that I just shared, but also because if you remember, like I had to come up every day with a different set of animated emojis to kind of convey how distressed I was about the pipeline. And it was also taking up a big chunk of my time. So here comes Maggie with the solutions.
Coming up with the re-architecture, we did recognize there were some good things about our previous architecture. Our governance was good. Our task groups were working for us. So really the thing that we needed to address was our sensor problem. And so how do we solve sensors? How do we get rid of them? And hey, there's this handy thing called datasets. Let's switch to those. That seems like the obvious solution. As we're switching away from sensors and starting to implement datasets, we're now noticing there's kind of this lack of visibility in our pipelines. While it was a pain point that when one sensor failed, everything failed below it, we at least saw the whole pipeline blowing up, essentially. But with data sets, if a data set fails, you don't really see what's missing below it. You no longer know what's out of date, and it's not visible in the Airflow UI of like with schedules, I have this concept of, oh, this data set should be roughly updating hourly or whatever the scheduled cadence is. With data sets, that schedule is somewhere in the pipeline. It's at your initial DAG that has the schedule, but your data set, I lose concept of like how frequently this should really be running. So how do we solve for this visibility issue of data sets? And so we really were like, well, I kind of just want this one DAG that shows me all of my DAGs. So we came up with a DAG of DAGs, and we called this our Control DAG. And this would show us all of our data sets getting produced, their dependencies, and all of our DAGs. But how do you actually build a Control DAG in a way that's scalable? That was going to be the big thing to solve for here. But we were actually like, hey, Airflow has a solution. When you're naturally defining your dependencies in Airflow, you get this rendered DAG dependency graph. And behind this is an API. And so we actually leveraged the API used to produce this graph that is static in the Airflow UI and turned this into a functional DAG so that every node here is a task that tells us when it's running, if it's failed. It's not the most visual in the UI, but the task view that we end up getting from our Control DAG allows us to see everything. And so we go from managing 100 individual DAGs to really just managing this one DAG and being able to click to the failures that we need to look at. So I'll just give a little context of how this Control DAG works. It's set up to be on our shortest schedule, which for us is hourly. So you see a run for every hour. You see everything that's running in those runs. So we're organized by schedule. So we have our hourly task groups and our daily task groups. And so you can see our hourlies are great. Everything ran and succeeded. Nothing to look at. And then on our dailies, we end up seeing what failed. And if anything didn't run downstream of it, you would also get that failure alert here too. So we can really see the view of what's offline at any given moment. And then I can actually click on these red dots and go to the DAG that failed and figure it out, get that data set back online. So a lot easier to debug. You get to see the origin point of any issues in your pipeline, which is something Marion lacked before. So that's what our Control DAG looks like. Actually, I want to point out one other thing. Because we had this, this visibility of our end-to-end pipeline, we initially, when we were designing DAGs, we were designing DAGs so that people could manage them. So you end up not having a ton of DAGs. You end up having a few DAGs with lots of tasks in them, just because in the UI, that's easier to manage. I'm waking up in the morning, I'm scrolling, looking for my red issues and fixing those DAGs. But because we now are confident that we have the full picture of all of our pipelines in one view, it encouraged us to actually break down our bigger DAGs and have micro pipelines, and the benefit of that I'll talk through in a minute. So let's just go back to Marion's sort of pain point screen and make sure we actually address these things. So when we introduce sensors, we sort of automatically solve for this resource issue and hitting system limits, because there just aren't sensors anymore that are competing for resources. And then we no longer have this cascade of failures. If one sensor breaks down, it doesn't trigger everything to fail below it. And to clean up, I just need to get that one failed data set to run, and it'll naturally clean up what's below it. So data set scheduling made our pipelines a lot more reliable. We no longer had timeout issues from sensors and all that jazz. So next, complex error diagnosis and scaling challenges. That was really solved for with our Control DAG. Again, it pinpoints exactly what the origin of your issue is, what data set is causing the downstream issues, and scaling challenges. Anytime someone introduces a new DAG, it's auto-monitored by the Control DAG. No one has to edit the Control DAG code because it's using that API. So it's growing with our DAGs now. So it's easier to monitor. So having this end-to-end visibility from the control DAG really increased our confidence in the pipeline. And then recovery, a lot of these points are solved for by the combination of the solution, but the recovery delays, because we were able to break down our DAGs into smaller units, we were really isolating failures and minimizing what was getting taken offline by failures. So that helped improve our recovery delays and development challenges. Now that we have micropipelines, things are truly only dependent on the things that they need to run. You have a lot more confidence adding something in the middle of your Airflow instance because you're like, oh, I'm not going to break this random project over there. It's really only dependent on this. And so micropipelines meant that we had failure minimization. And so all of this is really important because we're getting asked constantly to stand up more and more work, maintain the existing work that we have. So, and we're also now pushing data back to our customers to show them. So it's really important that we had a new architecture that was reliable and that we were confident in, our company was confident in. So if we go back to this failure rate graph, we hit this inflection point where we're like, oh, we really need to do something. Marion's running out of emojis. And so we end up implementing this control DAG. You see a kind of a drop here, and this is when we're just like taking off work that's not really used anymore. So slight improvement in our failure rate. And then this is when we really cut over to the control DAG, and you see a dramatic drop back down to 3% and much more stable. And so this has been live for 4 months now. So, and we also got to measure our hourly DAG runs improving by almost 38%. So our hourly runs were finishing faster than they were before. And we also noticed this with our daily DAG runs. Now, this wasn't something that we were really expecting when implementing the control DAG, but I think it actually came from the micropipelines of breaking down the DAGs. Now that you have things truly dependent on the right data sets, things are able to start running faster. They're not waiting for sensors that really aren't related to that work. And so we did just pull these numbers for this talk. So this has been running for 4 months. We only just pulled the numbers now, but we were pretty confident that this was a good solution just from lived experience. And I think our first responder here could probably talk to that a little better than I can.
Sure. Yeah, so my life changed for the best with that new implementation. Basically, now I wake up in the morning, I have my coffee, and then like I spend 2 minutes on the pipeline most days, and I just like copy and paste the message from the previous day on the Slack channel. I say like all good, all green. Or, you know, when there's a legit failure, because now if you have a failure, it's not going to be like due to architecture, it's going to be like, I don't know, like some sales guy put some wrong data in Salesforce, and so it broke our table. Not to accuse anyone of anything, but that happens. So then, you know, you fix the data point, and it's, well, first you found the root cause of the issue like very quickly just by looking at the control DAG. You fix it, and you just need to rerun that one task, and everything will like run on its own. So it's like, it's been a game changer, which means that I've had more time to focus on actually like looking into our data and doing more analysis and stuff like that. And so we were thinking that to conclude this talk today, we could do a little pop quiz based on like some of the insights that we found analyzing the metadata of our customers, the DAG and task metadata. So we've prepared like a few questions to see like, to share with you like some of those, insight we found about how people actually use Airflow. So, pop quiz. So as you can see, I decided to come up with a layout that looks like Who Wants to Be a Millionaire, but full disclosure, there's nothing to win. And so we're gonna do like a few questions. So the first one is, according to you, what's the most commonly used operator? And we're gonna do just a show of hands to see, what the room feels. So that's like, again, that's among our customer base. Like we get like those task and DAG metadata. And this is based on the last 30-day usage. So who's for option A, the bash operator? Okay, quite a few. The snowflake operator, option B. Yeah, not too many. Python operator. Wow, okay. I think they're leading the way at the moment. And what about the lazy automation operator? No one. And the answer is the Python operator. And by the way, the lazy automation operator doesn't exist. I made it up. But I can guarantee you that the day that it exists is going to be the most used operator, for sure. So if anyone wants to create it, please be my guest. And so these are it's written a bit small, but here these are the top 5 operators. So Python operator is 21% of the operators that I run, and it's followed by the Python decorated operator. And in fact, if you add them both, you get 1/3 of all operator runs within our customer base are those ones. And then you have the big query insert job operator, the branch Python operator, and the Snowflake operator. Next. Okay. What is the most failure-prone operator? So who's for option A, big query check operator? Okay, 1%. Option B, empty operator. Yeah, that's reassuring. That was there's always a phony answer in those games, so that was the one. Option C, SSH operator. Okay, quite a few. And option D, Python sensor. Okay, that's the winner here, and let's see. Well, in fact, it's the big query check operator, and this is really an operator that's there to check answers on queries. So I mean, it kind of makes sense. Well, I mean, the first one, the big query check, is because that operator, I think, is meant to fail. I mean, it's there to check if conditions are met or not. So I think people implement them because they want them to catch when there's a failure or when there's an issue. I think, yeah, I think that operator fails when the answer is not what it's expected to be. Yeah, a test. Yeah. It's a test. Okay. So here I looked more at categories of operators. So what are the longest running ones? So who's for option A, branch operators? That was the phony answer. Okay. Option B, the DBT operators. Okay, a few. Option C, batch operators. Yeah. And option D, Databricks. Yes. Okay. So we're not quite sure on those ones. Kind of split. And the answer is the Databricks operator. And if you see here, I mean, it's a bit small, but most of those operators this is running median task duration in minutes. And so most of the ones in that list are Databricks related, and it's several minutes. And it kind of makes sense because you usually run entire notebooks. Sometimes you run AI/ML workflows in Databricks. So, okay, now next one. How many tasks in a DAG? So this one I like it, and spoiler alert, I was very surprised by the answer. How many tasks does a DAG typically have? And that's on average. I guess, no, it's not on average. Here the question is what's the most frequent number of tasks in a DAG? Who's for option A, one operator? Okay. And is that speaking from experience or answering from experience of your own pipelines? Maybe? Yeah. Yeah, a bit. Option B, 5 operators. Okay, few people. Option C, 10 operators. Yeah. And option D, 20 operators. Okay, so I feel the winner here is 1 operator for some reason. And I don't think Airflow was meant to do just 1 operator DAGs, but still we can see a few of those. And the correct answer is 5 operators. And I thought that graph was interesting. So you have almost a third of DAGs that have 5 operators exactly. So that's really the winner. But most interestingly, you have 90% of the DAGs that have less than 20 tasks. Of course, you have outliers. Our maximum within our customer base is more than 4,000 tasks. I'm curious to see what the Airflow UI looks like on that DAG. But in our case, Maggie showed you how we use those task groups. We have more than 20 operators on most of our DAGs because of each task can be broken down into several subtasks. So I was quite surprised to see that 5 operators was the most common. Oh, sorry, I meant tasks. Yeah, I meant tasks. Did I say operator? Sorry, I'm jet lagged. Okay, so what's the most frequent scheduled hour for a DAG? And that's in UTC time. Option A, 0. Yeah, that's option B, 8. Option C, 12. Not so many. Option D, 20. There's some people that like the 20 UTC. Okay. And the answer is 0. And if you look at the distribution, I mean, I was also quite surprised by this one because I would have expected more like maybe like the 7 UTC, which is like midnight Eastern Western time, or 4 UTC, which is midnight Eastern time. And I would have expected like some more peaks. And in fact, it's like quite well distributed, with maybe like the exception of like the last few hours of the day, which correspond really like US times. It's like the afternoon, so probably, you know, like you don't want to schedule your operational DAGs in the afternoon. So now, like, what about the minutes? Like, what's the scheduled minute of a DAG? Is that more like at the top of the hour, after 15 minutes, 30, or 45? The answer, at the top of the hour. And like basically almost 2/3 of the DAGs are scheduled at the top of the hour, which, I don't know, maybe like it's better to kind of space them out a bit. So yeah, that's it for the pub quiz, and that's it for our presentation. Well, I'll let Maggie conclude on our presentation.
Yeah, so we really wanted to be able to get back to data and answering data questions. So we really needed to get Marion out of orchestrating our pipelines and get Airflow back to orchestrating our pipelines. So that was the need for this re-architecture. And I think the conversations our team had, and also conversations that people are having with our customers, it really pinpointed that there's this lack of observability in the product. So they're actually announcing Astro Observe, which is trying to add observability into Astro natively, so that you'll see more Control DAG-like features and observability in our product, so that you don't need to go out and build this. So.